Mr. K. Balraj is working as a polymer consultant and teaching fellow in the area of polymer science and engineering at CEG Anna University, Chennai. He has completed AMIE in Electrical Engineering at the Institution of Engineers India, Calcutta and MTech Polymer Science and Engineering at CEG Anna University. He is also pursuing his doctoral research work in polymer technology. His area of specialization includes polymer rheology, polymer processing, characterization and testing of polymers, polymer blends and composites and insulation technology. He has in-depth experience on plastic properties, testing methods and the relevant standards. He has more than 15 years of teaching experience in polymer science and engineering, including instrumentation in polymer industries, engineering plastics, conducting polymers and rubber technology at CEG Anna University. He has guided more than 30 MTech students in their research projects. He has presented more than 20 research papers in the national and international conferences in the area of polymer science. He has published 10 research papers in the peer-reviewed journals.
Welcome to UGC lecture series in Polymer Science. In Polymer Science, the course is Polymer Processing and Mold Design. This is the fifth part. In the last class, we have discussed about the two main types of thermoforming, that is vacuum forming and pressure forming. In this episode, we will discuss some of the more variations in thermoforming, particularly with respect to the vacuum forming technique. Followed by, we will discuss about casting, how casting is applied to polymer processing, and then another important polymer processing method, which is rotational molding. First, we will see some of the variations in the vacuum forming. First one is the straight vacuum forming. In this method, as the name itself implies straight, vacuum is straight away applied at the bottom of the mold. That is, as usual, the first step is the plastic sheet is clamped in a frame and it is softened, it is heated, as a result it will get softened until it reaches an elastic state. It is then placed over the female mold cavity and the air is then sucked out of the cavity by vacuum, that is, vacuum is applied at the bottom of the mold. Now, the atmospheric pressure forces the hot sheet to take the shape of the contour of the mold. Now, when the plastic sheet has cooled down sufficiently, the formed part can be removed from the mold. That is, once the plastic sheet comes in contact with the mold surface, it starts cooling. As a result, it will slowly solidify. Now, thinning at the upper edges of the part usually occur with relatively deep female molds. That is, when we prepare a product of more depth in this method, then there will not be uniform thickness on the uniform thickness with respect to the product could not be maintained. So, that is one of the drawback here. The hot sheet being drawn first to the mold center causes thinning. Now, the sheet area at the edges of the mold stretch the most, therefore, that becomes the thinnest section of the formed item. Now, straight vacuum forming is normally used for simple and shallow designs. So, this is a typical scheme of straight vacuum forming. In the first step, a plastic sheet is clamped just above the female mold, and then a vacuum is applied. Vacuum is drawn inside the mold. As the name implies, straight. So, the vacuum is straight away applied at the bottom of the mold where the vents are provided. Now, because of the vacuum that is the mold is subjected to, now this plastic sheet will be forced to take the shape and contour of this mold like this. In the next step, as and when it contacts the mold, it gets cooled down, therefore, it gets solidified. As a result, a solid product is formed. Now, areas of the sheet that touches the mold last are the thinnest. Therefore, thinning takes place. You could see the product thickness is not uniform. These are the thick areas. These are the areas where the plastic sheet touches for the first time, whereas these corners, the plastic sheet would touch these corners at the later time. Therefore, thinning takes place. This is one of the serious drawback with respect to straight vacuum forming. This could be overcome by other methods that are the other variations are plug assisted vacuum forming, bellow forming. So, bellow forming is again a variation of plug assisted vacuum forming wherein a pressure bubble is used. Another type is vacuum snapback forming. In this method, a vacuum is applied in a systematic way, one time at the top and the other time at the bottom. So, that is why it is called snapback forming, vacuum snapback forming. These are the detailed schemes with respect to this plug assisted vacuum forming and billow forming and vacuum snapback forming. We will see one by one in detail. Now, before that, what is a plug assist? A plug assist is a mechanical device which is used to aid or assist sheet stretching prior to total contact with the thermoform mold. So, this is the mechanical device, a plug shaped device. So, normally this is used to stretch this hard plastic sheet. In the earlier straight vacuum method, there is no such plug assist. As a result, the plastic sheet is not stretched, rather on application of the vacuum, the plastic sheet will be forced to take the shape of the mold. In the process, uniform thickness could not be maintained. But then when you go for a plug assist vacuum molding, where before the vacuum is applied, this plastic sheet could be stretched by using this plug. So, that is how this plug assist vacuum forming is different from the straight method. This is a typical scheme of a vacuum plug assist vacuum forming, wherein as usual the first step is the plastic sheet is clamped just above the female mold. This is step 1, and also it is subjected to heat, thereby it gets softened. And the second step, the plug moves down, the mechanical plug moves down, and this will stretch the plastic sheet. The height to which it is to be stretched can be determined, can be calculated in such a way that will result in superior properties with respect to mechanical strength. In the second stage, stretching takes place. In the third stage, the plug moves up and then a vacuum is applied at the bottom. So, that is, there will be a vent that will release all the atmospheric air in a single shot. As a result, a huge vacuum will be created that will force this stretched plastic sheet to take the shape of this mold. So, this is plug assist vacuum forming. So, the other variation of this plug assist vacuum forming is instead of a plug, a pressure bubble is formed. This is also called billow forming, billow vacuum forming. The pressure bubble plug assist vacuum forming technique is used when a sheet is to be formed into deep particles. At the same time, it should have good thickness uniformly. In such a cases, we go for this pressure bubble plug assist vacuum forming, which is also called as billow forming. The framed sheet as usual is heated, then controlled air pressure is used to create a bubble. This plastic sheet would be allowed to take a shape as though it looks like a bubble. When the bubble is stretched to a predetermined height, again to how much extent the bubble has to be stretched could be predetermined, because that is going to have a direct effect on the final mechanical properties of the product. The male plug assist, which is also normally under heated conditions, is lowered to force the stretched sheet into the cavity. Now, the plug speed and shape can be varied. The plug necessarily need not be of same shape for all the type of products. The shape could also be varied. That will ensure that there is a good material distribution with respect to the mold, resulting in uniform thickness. So, this is a typical scheme for plug assist vacuum forming pressure bubble method. The first step is as usual, the plastic sheet here shown in this dotted line is heated and it is sealed across the mold cavity. Just above the top of this female mold, it is sealed. In the second step, now air is allowed at the bottom. This will blow up the plastic sheet to take a shape of the bubble. And then this height, as we have seen, this height up to which it could be blown could also be predetermined. In the next step, a plug shaped a plug which is of shape roughly equal to the cavity or contour of this mold will press it down, forcing the sheet to move to the mold. At the same time, when the plug reaches its lowest point, because the plug could not reach the bottom of the mold, rather up to what extent this plug could move is also controlled. As a result, once it reaches to the maximum point, now the vacuum is drawn. Now the vacuum is drawn through this bottom vent, which will pull the plastic against the mold walls. Therefore, this will ensure that all the part of the plastic sheet would touch the surface of the mold at the same time, that will result in uniform thickness. The next variation is in the vacuum forming is vacuum snapback forming. It is another method used when the heated sheet of plastic must be pre-stitched. So, we normally go for all these variations to ensure that the plastic sheet is stretched, because there are number of advantages with respect to stretching the plastic sheet when it is at hot conditions, that will improve its surface morphological properties. Later on it will also increase the impact property, that is why we go for stretching. Now, the sheet of plastic is brought into contact with a cavity box, where vacuum is then applied partially, not vacuum is not applied fully, is applied partially in order to draw the plastic sheet into the box. The next step, the mold is brought into contact on the opposite side of the sheet, where vacuum is turned off and then applied to the mold. Now, this will pull the sheet against it. We will see how the vacuum snapback form is formed. The first step, a hot sheet is clamped and then clamped just above the female mold. In the second step, a vacuum is applied at the bottom vent. So, as a result, this will stretch, and then the stretching height could also be again predetermined. Now, in the third step, instead of moving the plug down to force this sheet to take the shape of the mold, here what we do is we close the vacuum wall at the bottom, and then at the same time we would release the vacuum at the top. This as a result, this plastic bubble shaped plastic sheet would be forced to take the shape of the mold in the opposite way. Now, instead of forming the shape in the female mold, now the product take the shape of the male mold. So, as a result, in the next step, once this plastic sheet gets solidified, now this will take the shape of the mold. Now, because here vacuum is applied at first at the bottom, at the next step at the top, now the plastic sheet is stretched down and then it is pulled up. So, that is why it is called a vacuum snapback forming. Now, if you look into the advantages why we go for vacuum forming, the technique is simple, and then the capital cost associated with this less because of the reduction in the mold cost, and also suitable for large formings. A bigger sized product could also be prepared. Now, this is widely used for thin walled packaging applications, particularly for sandwiches, in electronics, and then in the blister packs. Now, this is also useful for short runs. So, that means the production in terms of volume is less, and also most of the times this vacuum forming is used to prepare a prototype model for a big apartment complex or a park complex. Likewise, you want to prepare a prototype, then we go for vacuum forming. Now, if you look into the drawbacks or the disadvantages, mainly the thickness of the wall. Thickness of the product would not be uniform throughout the product, therefore, this is a major issue, and also the finishing work is required, it has to be trimmed up. So, that will also again result in wastage of time as well as material, and the polymer is heated twice, that is common with respect to thermoforming. That is, the plastic sheet has to be extruded first, there also you heat it one time, and then the plastic sheet is to be softened. So, therefore, you heat it twice, once to make sheet and the other time to take the shape of the mold, and then limited range of shapes are available. One cannot go for empty number of varieties, and the detail not great due to low pressure differential, because we apply only vacuum. So, therefore, detailed shape with respect to products could not be prepared in vacuum forming. Next type of thermoforming is matched die thermoforming. Here no positive or no negative air or pressure is applied to the mold. So, all the molding is simply done by means of only mechanical means, and then there is less detail than most of the other process. Just because it is done by mechanical means, the complication with respect to the machine construction is less. In the matched die thermoforming, as usual, a heated sheet is placed between two matching male and female molds, which are also heated to the temperature at which the plastic sheet is going to soften. And the next step, it is pressed to each other, and also you have vent that will release all the trapped air packets by vacuum through holes in the molds. Unless you remove these air packets, this will greatly reduce the impact property of the product. Now, if you look into the advantage, the system enables very good detailing of surfaces, because once you prepare a matching mold, a male female mold, one can go for more detailed surface finish, but it is relatively costly due to the need of accurate tooling and also close tolerance. So, the tolerance required is very high, because these male and female mold, once is pressed together, it should match perfectly. So, this is a typical scheme of matched die thermoforming. This is the positive mold or male mold, and this is the negative mold or female mold. So, as usual, a heated plastic sheet is just clamped over the female mold. Now, there is no vacuum or air is applied, simply the positive mold, once the plastic sheet gets softened, this positive mold is just going to come down, and then by mechanical means the plastic sheet will be forced to take the shape of this mold. And the next variation in thermoforming is twin sheet thermoforming. Now, why we go for this method is to produce hollow parts starting from two sheets that can be perfectly pinched together. Now, the excess material can be machined without any reduction of the weld strength. The weld strength is wherever the plastic sheets do join, the mechanical or the tensile strength at that point would be reduced. Therefore, that is what we mean by weld strength, and no such weld strength phenomenon would occur in twin sheet thermoforming. So, therefore, this is again an advantage, and different thicknesses and different colors, either one sheet in one color, another sheet in another color. So, all such variations in colors is possible, and surface finishing can be used between the two sheets. So, this is a typical scheme of twin sheet thermoforming. In the first step, two heated sheets are just placed in between the top and bottom of the female mold. In the next step, the molds are closed, which will ensure that the plastic sheets are sealed. Plastic sheets are sealed at the both the ends. In the third step, vacuum is applied at the top and bottom of the female mold. At the same time, air is also pumped in. So, as a result, the sheet would be forced to take the shape of the mold in this way, and also a hollow space would be created in between this. As a result, and the next step, once the products get solidified as it comes in contact with the surface of the mold, now the one half of the mold is moves up, and then the formed product could be removed. This is how a twin sheet thermoforming process is. Next, we will move on to casting. So, casting is more familiar with respect to metals, because in metals liquid will conform to the shape of the vessel that holds it. That is the fundamental principle. In metal casting, what we do is we heat a metal, and then we just pour it in a mold where it gets solidified and take the shape of the mold. That is what is casting. So, therefore, this process basically involves pouring molten metal into a patterned mold after the part to be manufactured, which extract heats. As a result, it will cool, and then removing the metal from the mold. Now, if you look into the important considerations in casting, the flow of the molten metal into the mold cavity, this is again an important consideration. The solidification and cooling, how fast or how slow the metal cools inside the mold, and then the influence of the type of the mold material, whether the mold material is of aluminum or whether the mold material is of steel, because there is lot of heat transfer issues that takes place when you pour a hot molten metal into another mold cavity, which is again made of another metal. So, therefore, these are the general consideration in castings, but then in polymer the casting is totally dealt in a different way. You have solution casting and film casting, a number of ways by which this casting method could be adopted to prepare plastic products. So, the more common is the film casting. It is a widely used manufacturing process for polymeric films, for preparing polymeric films. And then the other variations in this are blow casting, that means using a blow molding machine to cast, and also extrusion molding machine to cast a film. Now, normally the latter one, that is the extrusion film casting, is the normally used method that will ensure that the cost is less, and also where we need more low quality films that has to be prepared at a high production rate. Now, if you look into the advantage of film casting, particularly with respect to polymers compared to other methods, the method is relatively fast. This is a continuous process, therefore, the method is fast, and then more uniform film cooling at the extrusion die exit is possible, and then the possibility to work at relatively higher temperatures. One need not bother about the high temperature at which the extrudate is going to come out of the extrusion die. As a result, this will improve the production rate. And then with respect to film thickness, if you could able to achieve continuous cooling, then there is no problem with respect to film thickness, and at the same time the optical properties would also be improved better in the extrusion film casting. If you look into the process of film casting, all these methods make use of an extruder. The extruder is the same single screw extruder what we have seen earlier in the extrusion molding process. Only difference is it will have a plain extrusion die that will ensure that the extrudate comes in the form of a film. The raw material, that is the polymer, along with additives. The additives are normally the colorants that are added to give aesthetic color to the film, is introduced into the extruder. As we have seen earlier, any single screw extruder, there will be 3 different zones: feed zone, a transition zone, and a mid-ring zone. Now, at the feed zone, that is at the hopper end, the polymer across will be controlled using a regulation valve. This will ensure that the required pressure increase is maintained, because in a single screw extruder a high pressure has to be created that will ensure that the screw moves in the forward direction. At the same time, it injects the resin into the die. It is followed by a filter constituted by a drilled plate, which is normally called as a breaker plate. A breaker plate is nothing but a stainless steel plate wherein a number of holes are drilled on the surface of this plate. Now, the melted polymer is allowed to exit through this breaker plate, and then the polymer film that comes out is cooled by a roll at a constant temperature. Now, this roll is going to be maintained at a constant temperature that will ensure that the polymeric film is cooled uniformly at across the entire surface of the film. And the next step, an air jet, or sometimes one can go for spraying of water, is blown on the polymer to obtain a good adhesion between roll and the film. As the film gets winded on to the roll, there should be some good adhesion. And again another air jet is used that will ensure that the film is released after it is solidified, and then it is taken off for the further collection point. The film has to detach easily from the earlier roll. So, therefore, either a air jet or water spraying could be used. Now, the roll is once the process is over, the roll is dried by subjecting it to a very high hot air that will prevent any packet formation. So, this is a typical extrusion film casting scheme, wherein this is a single screw extruder. It has a extrusion die that will ensure that whatever the polymeric pellets what we drop in the form of a powder or granules or pellets will take a shape of the film. Now, the film will be passed through 2 rollers. So, this is the first roller is to cool, and then the second roller is the takeoff. and then it is and then this will be slowly collected over the winding drum. So, a continuous film could be casted and then it could be collected. Next we will move on to rotational molding. So, this is a typical scheme for rotational molding. In this you have a mold in which the plastic powder along with the additives is charged. The mold is normally aluminum mold because this mold has to be rotated at a very high speed. Therefore, weight of this mold is going to have a effect on the cost of this process. Therefore, generally aluminum mold is preferred. And then the next step, the mold is rotated rotated inside an oven that will ensure that the mold is subjected to uniform heat. Now, in the next step, the mold is air or water cooled to allow the part to solidify. The product will get solidified. In the next step, the tool is opened and then the product could be removed. So, this is a typical rotomolding process. These are the 4 steps: charging the mold or preparing the mold, followed by heating the mold, cooling and then demolding. In the first step, the material is a predetermined set material is charged into the mold. Now, we could see the mold could be rotated biaxially, that is, it could rotate with respect to this axis as well as this axis. So, likewise it can rotate like this and it could rotate like this. So, this biaxial rotation would ensure that the entire material once it is softened, this will get dispersed or this will coalesce on the surface of the mold uniformly with respect to this biaxial orientation. In the next step, it is cooled. A sudden heat reduction would take place on the surface of this mold. As a result, the product gets immediately solidified and then this is the final formed product that could be taken off. So, the last step is of course demolding, which is simply removal of the product. Now, looking into the details of preparing the mold, the process begins with filling a hollow mold with a predetermined quantity of polymer powder or resin. This could also be pre-compounded to the desired color or the coloring agents could be added there also. Now, the oven is preheated by either conduction mode or by convection mode. The normal temperature range is 262 to 370 degree Celsius for most of the polymers. When the powder is loaded into the mold, then the mold is closed, locked, because it will be subjected to biaxial rotation. Therefore, the mold has to be completely locked, and then the next step, it is loaded into the oven where heating and fusion takes place. Inside the oven, the mold is biaxially rotated as the polymer melts and it will form a coating like film on the inside of the mold. Now, the rotation speed is again an important criteria in the rotation molding. If it is slow, that is less than 20 rotations per minute is the normal speed. We will see what happens, how this speed is going to affect the product. And then the process is not centrifugal. The centrifugal is principle is not used here in the product formation. During this phase of the rotational molding, the process timing is critical, that is the speed as well as the time which the mold is subjected to rotation. If the mold spends too much time inside the oven, then that will result in degradation of the polymer. So, polymers will normally degrade above its melt temperature. So, if it is going to degrade, still a product would be formed, but then this will reduce its impact strength. At the same time, if it spends too little time inside the oven, the melting of the polymer will be incomplete. So, therefore, there will not be uniform melting of the polymer. So, as a result, there will not be complete coalescence of this polymer on the mold wall, thereby creating bubbles in the item. Therefore, large number of bubbles would be just embedded on the surface of the product, that is going to decrease its impact strength. So, therefore, the cooling the molding time is critical. The next step is cooling of the mold. After the melting has been consolidated to the desired level, the timing is right, that means optimum timing has to be calculated, the sufficient time that will ensure that correct cooling of the mold. The mold is removed from the oven and cooled. Cooling of the mold is typically done with air, and also cooling allows the polymer to solidify to take the desired shape. The last step is of course unloading or demolding. When it has cooled sufficiently, the polymer can retain its shapes, and then the product could be mold is opened and the part is removed. So, these are some of the advantages of rotational molding. Small production run, large part could be prepared, low tooling cost, product would be stress free, and then short product development. The serious drawback is cycle time. Cycle time is normally for 40 to 45 minutes would be a typical cycle time for a product, and then a limited material choice, difficult to automate, poor image, and these are some of the products that are made of rotational molding. Usually the syntax tanks, large size syntax tanks either for domestic or industrial use is prepared using rotational molding. The bumper part of automobiles also likewise. So, to summarize, in today's episode we have seen some more types of thermoforming, particularly with respect to vacuum forming, plug assist forming, billow forming, and then pressure bubble or vacuum snapback forming, and why we go for all these variations in thermoforming. And then in the casting we have seen one important casting process applied to polymers, which is film casting. And then again rotational molding is again another important process, polymer processing operation that is commercially used to prepare large sized hollow products. After looking into this episode, these are the questions that we should try to answer. What is a plug assist? What are the advantages and disadvantages of vacuum forming? What is casting? What is thermoforming? What is rotational molding? Thank you.